All right, so we're doing January 2023. We're finishing that exam. Any questions people have? And I'm doing number 12. Number 12, January 2023. So anybody that's in this class right now in person, if you haven't done this, let's not leave it blank, please. All right, this is a circle fact. Right, we have DC to CBs in a ratio of 4:5. We have talked at length when I see numbers in a ratio, as long as it's not a partition question at least. If the numbers are in a ratio, I put X's with them. So DC, you're going to see me put 4X, and BC, you're going to see me put 5X now. Now I have to remember the rule. This is a tangent right here, and this is a secant. The rule for how to find the lengths of tangents and secants, here's the rule. I don't know what the cold hard fact sheet says, but this is what we used in class. Whole times external equals whole times external. That's the rule I need. All right, that's the rule I'm going to need there for the lengths of tangents and secants. All right, so let's go to the tangent first. Tangent, the whole and the external are the same value, 24 and 24. So I say 24 times 24. Now look at the secant. The whole secant, I have to add up 5x and 4x. So in for whole, you're going to see me put 9x, 4x plus 5x, times its external part, which is 4x. So the 5x never comes into play here, except when I add it for the whole. Now, I think we did a problem similar to this yesterday when we did cross multiplication on a proportion. I do get 36x squared. And on the other side, anybody want to help me out? 24, 24? I don't know what that is in my head. Sorry. 576. And you guys always want to go square root crazy. You can't go square root crazy until the x squared is by itself. So divide out the 36, then you can go square root crazy. X squared equals, I still need help there. 16. X squared equals 16, so x equals 4. Haven't I been telling you? They want you to fall in the traps. And look, 4 is an answer up there. Because you're all proud of yourself. You did this difficult problem. You remember the circle fact. And circle 4. Circle me. Circle me. That's not what we're asking, though. Go back. What's the length of CB? And if you look at CB, we labeled that 5x. So we need to multiply that 4 by 5. And that's how we end up with 20 as our final answer. Look, there it is. 4 is up there. Pick me. You have to stay there 2 hours. All right, you have to. So you might as well just take your time. And if you find X, stop yourself and say, is this really the answer I'm looking for? You good? Yeah. Charlie? 35. 35? We're going deep. All right, as I'm putting this up here, there's one part 4 question. The test consists of 4 parts. Part 4 is one question worth 6 points. Expect it to be some type of proof. That's what it's always been in the past. Am I guaranteeing it's coordinate geometry? No. I have no idea what's on the exam. But it will probably be some type of longer proof. All right, so I need a grid here. Insert, edit, view grid. So there's multiple parts here. I'll make a deal here, Charlie and everybody else in class. I won't go through the whole thing, but we'll discuss, all right, how would you prove it a right triangle? Because you guys, If you don't know how to find slope, midpoint, distance by now, we got work to do. All right, so -3, -1 is D. -1, 1, 2, 3, 4, 5, 6, 7, 8 is U. It's 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. All right, this is a real good question, not just for what they're asking, but also I get to tell you some other special facts here. All right, I'm not allowed to grade this exam, your exam. Okay, I'm not allowed to grade your papers. Other math teachers in the department are going to have to grade it. So please be neat. Okay, please be neat, because for me, if I see the student's paper that I don't know and it's just it's just hot mess everywhere and I can't follow it, chances are probably I'm not going to take it too seriously. All right, so please be neat. I'm not allowed to look at your exam at all. All right, so whoever's looking at it, please be neat, especially if you're asked to do a coordinate proof. I'm asked to prove triangle DUC is a right triangle, so I need to show there's a right angle in here. And if you take a look at the diagram that I have up here, we can probably guess the right angle is probably going to come at you, right? So make your work neat. All right, here you go. Step 1. How am I going to show that that's a right angle? If those two lines are perpendicular, how do I know they're perpendicular? I use their slopes. So the first thing I'm going to say is, hey, let's find the slope of DU and let's find the slope of UC. And hopefully by 2 weeks from now, you'll know how to find the slope. Rise over run, or y2 minus y1 over x2 minus x1. So I'll do that real quick. That's easy to do. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 2. So it looks like du is 9 over 2. And UC is up 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's negative. What do you notice about those slopes? They are negative reciprocals. So in step 2, nice and neat underneath, right next to it, so we can follow your order of thinking. Hey, du is perpendicular to UC because slopes are negative reciprocals. Then you could tell me, think of it like this. Think of it like we're doing a statements reasons proof. After you write something's perpendicular, now you could tell me angle U is a right angle because perpendicular lines form right angles. And now you could tell me it's a right triangle because it has a right angle. Now, do we need to see step for step to get full credit? No, you write as much as you can. All right, that you think you need. Write as much as you can. All right, there's no fault to writing more, but there is a fault to writing little. All right, so write as much as you can. So there's part A. We're good there, Charlie, making it into a right triangle. All right, next part, which is, all right, let me copy this out here. And there is partial credit. You know, just because you get a little part wrong doesn't mean we're going to take off all 6 points. There is partial credit. All right, next part. Scale this down a little. And as I'm doing this, another point, everything in parts 2, 3, and 4 need to be done in pen, except if you do a graph. Now, hey, for this problem, this graph that I did right here can be in pencil, but all this work I'm doing right now has to be in pen. All right, parts 2, 3, and 4 all have to be done in pen unless you're doing a graph or a construction. That needs to be done in pencil. Is it okay if you do everything in pencil and before you hand it in, you go over it in pen? That's fine. What about bringing an erasable pen? Fine too. All right, but the graph only can be done in pencil. Everything else needs to be done in pen. All right, next up, point U, where's point U up there, is going to be reflected over DC, and we got to locate U prime, forming quadrilateral DU, CU prime, Jesus. And then prove that's a square. So DU, CU prime. So I know U prime's got to be somewhere over here because we always go in a clockwise or counterclockwise order when we label a quadrilateral. So I need to get U over here by reflecting it over DC. All right. So how am I going to be able to reflect that? I'm going to use slopes again. All right, I'm going to use slopes. So if I'm I can either go from U to C and match it, or I can go from U to D and match it. That's what I'm going to go. I'm going to go U to D and match it. So ready? I'm going to go over 1, 2, and I've already done this, and down 1, 2, 3, 4, 5, 6, 7. Wasn't it 9? It was 9, right? Over 2, down 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So what am I going to do? I'm going to go down 2 over 9 again. Down 2 over 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's U prime. Okay? So with reflections, I just match the slopes on either side. Now I have to prove that's a square. I know I'm getting messy, but I want to make sure we know where the square is here. Okay, so I got to now prove that's a square. And this is where I'm not going to do this all out, but let me talk to you guys. How would you prove that's a square now? Options to prove it's a square, because I want to make sure you realize, oh, that wouldn't be enough what I just said, or that would be enough. What would be your way? Prove the diagonals congruent. I would need one more, because that would make it a rectangle. But I would need, if you can do that, draw in the other diagonal, prove the diagonals congruent, but you're going to do something else that makes it into a square.
Sides.
You can prove the sides congruent. Here's how I would do a square for you guys. Prove all 4 sides congruent using what formula? Distance. That makes it a rhombus. Now, how do I make it into a square? Show it has a right angle, which you already did. Okay? A quadrilateral that's got 4 sides congruent and 1 right angle makes it into a square. You do not have to show all 4 angles. Can you? Yes. It's overkill. You only need 1, though. All right, you only need 1. So 4 distances, and then go back and say, hey, U was a right angle. That makes it into a square. Good try. Everyone else all right? I know that I looked at this one when this came out in January, and this is tough, knowing that how to get U prime. But again, use slopes. I could do it this way, or I could do it U to C and match it down here. I could go down 9 over 2. Or anything else from this exam? Because we're done talking about it. If there's no other questions, and you guys can, if there's still blanks, you guys got 2 weeks to review. So we're all good. Okay. I have to stop talking as much up here now. We went through 5 days in the packet of topics that are commonly on the exam and probably will be on your quiz on Thursday. I need more of you guys practicing on your own. All right. Here are first, go through the June 2022 right now that I asked you to bring to class. Circle these problems. These are the problems I'm asking you to do tonight if you want to try them. All right. These are review. I'm not wasting time on doing Hills and SAS. I'm not wasting time on doing area of a sector, similar triangles. I'm not. We don't need to do that anymore. Here are all the questions that pertain to those we did over the last 5 days. All right, so if you want to go through your exam right now, June 2022, that I asked you to bring to class, do so. And we're going to be working in this exam today and tomorrow. Okay, so make sure this exam gets brought to class tomorrow. And again, these are all review. And I say review, I mean the last 5 days. No reason to waste class time. And they're all part 1s, multiple choice. Tomorrow we'll get into the bigger ones. Everyone got a copy down? All right, I'm going to hit on a few problems. I'm not going to take much of your time because I want you guys to practice some stuff on your own. I'm going to hit up a couple problems we haven't talked about yet. All right, we haven't talked about since we did it in that unit. We all good now? We good? Eliona, you good over there? These? Okay. All right, here we go. First one. Let's look at 7, everyone. Go to 7. Look at multiple choice 7. We have AE congruent to DE. And then it asks me which of the following is true. Anybody see a special type of triangle in this diagram? Isosceles, name it. Because Spence, I see a ton of triangles. Which one's the isosceles one? AED. Everyone see AED is isosceles. And we know isosceles, not only are the sides congruent, but angles across. So make sure in this triangle only, you look directly across. All right, so angle A congruent to angle D. I just want to make sure we're good that those are the two angles that are congruent and nothing else. And we are good to go. EAC congruent to EDB. I just want to make sure you're good on identifying those triangles and where those angles. Any issues in a triangle, congruent sides across from congruent angles? Number 9. What's good enough to prove this a parallelogram? Okay, which facts up here would prove ABCD a parallelogram? All right, let's see. If 1 was congruent to 3. All right, so let's pretend, yep, 1 congruent to 3. What type of angles are those? Corresponding. So if they're congruent, there should be a set of parallel lines. Where are they? If 1's congruent to 3, what lines would be parallel? Those corresponding angles belong to what lines up here, guys? Lines. Use KL, M, and N, please. That's how we name it. M and N would be parallel. Is that good enough? Just take a look at my diagram too. Is that good enough just to say it's a parallelogram? One pair of sides. No, I need both pair, right? I need both pairs. So that's not good enough, having one pair of sides parallel. All right, let's go to number 2. 4 congruent to 7. Where's 4? Oh, there it is. All right, what type of angles did I just mark there? Alternate interior. All right, name the parallel lines then. If 4 and 7 are congruent, what lines would we be parallel? K, L, M, N. KL. Is that good enough? If K and L. Again, same thing as number 1, right? I need both sets, not one set. Not good enough. All right, let's keep going. How about now if 2 and 5 are equal and 5 and 7 are equal? Going to be good enough. Well, let's see. 2 and 5. They're alternate interior. What lines do they belong to? K and L. Everyone agrees? K and L? All right, so I have K and L parallel. Now let's go to 5 and 7. They're corresponding. What lines would be parallel now? Here's 5. Here's 7. M and N. Good enough now for a parallelogram? Darn right. Both pairs of opposite sides parallel. One pair won't cut it. And if we went choice 4, you'd have the same set parallel. All right, 1 and 3, 3 and 4 make the same set of lines parallel. All right, not opposite pair. We're all good on 9? All right, let me do a couple more and you're on your own. I lied, I guess. I want to do this review one. Let's see if you remember anything. So 13. We did this one yesterday. I'm not doing this one. Sorry. We did this one yesterday in your notes because I remember finding EG where I'm not doing that one. We did that one in your notes. Here we go. 16 then. Which pair of triangles cannot be proved congruent? Okay, review. We didn't review this during the 5 days. How about those 5 methods of proving triangles congruent? What do you got? SAS, side, angle, side. Side, side, side. Oh boy. Angle, side, angle. What if the side's not in between? Angle, angle, side, and then one everyone forgets. Only only can be used in a right triangle, HL. All right, so which one up here is not one of those theorems? Number one, what is it? Is those are congruent by what method? I don't think HL, because the hypot A, B, and BD would be the H, and I don't know they're congruent. Everyone see BC is reflexive? This is side angle side. What about number two? Remember, you can mark reflexive or vertical angles on your own, nothing else. So these have, number two has vertical angles. So this would be angle, angle, side. What about three? JL, congruent to JL. So this would be side, side, side. And why is four going to be the one that's not congruent? What's the problem? Angle's not in between. All right, so that's not side, angle, side. And there was never, we're in June now, we're done with the course. There's no side, side angle. Please don't put that and embarrass ourselves. 16's done. How many more do I have? I don't think I have much more. Nope, I got one more. Two more, sorry. 19. Looks like we have to do a diagram here to help us out. Diameter ROQ of circle O. So circle O tells me that's the center. Diameter ROQ is extended through Q. All right, so everyone, here you go. Here's ROQ. Extend it through Q to point P. That's awful, sorry. Come on, you're better than that. Extend it to point P, and PA is tangent. Only hits the circle. Tangent only hits the circle. One spot, right? So PA. Arc RA measures 100 degrees. What's angle P? So in our homework, you guys that came in late, our homework, Abbott asked a question similar to this, but it dealt with the lengths of these. So we did whole times external equals whole times external. This isn't lengths, these are angles. Is angle P inside or outside? Outside, discussion's over. If you are asked to find an angle located fully on the outside of the circle, you do 1/2 the difference of the arcs in between. These are just the circle facts we got to remember. So we do 1/2 the two arcs in between. What's the bigger arc in between? That's going to be 100. But the problem is I don't know the smaller one there, QA, but can you find it? Hopefully you can. What did I draw in first? What was ROQ? So cut it into two semicircles. Right? Semicircle measures 180. That's already 100. That's got to be 80 degrees. All right, look for your diameters. And now we're off to the races. So what's that? 1/2 of 20? 10? Circle fact. That's all it was. Circle fact. The angles on the outside, we take their difference. And then go ahead to 21, right on the bottom of your page there. Go ahead, let's fill in everything. Let's read the directions carefully here. EB is congruent to FB. So EB is congruent to, FB, jeez. EF is perpendicular to FH, so we can put a little something there, right? EF and FH. And that's about it. All right, angle measures now. 62 degrees for angle E. Angle C is 51. All right, where do we need to get to, guys? Angle FHB. So I got to get to that angle right there. Also, it just says it's a quadrilateral, not a parallelogram, so no properties here. Just says it's a quadrilateral. All right, can you help me fill in anything else? Remember, they gave you these two sides are congruent for a reason. Use it. Use it. They gave you that was a right angle. Use it. All right, can I fill in any more degree measures here? I hope so. I'm getting there. Oh, they told me ABCD was I'll get to that in a second. ABCD is a parallelogram. Spence.
BFE is 62.
Thank you. Hey, they told us these sides were congruent because that's an isosceles triangle. Across from the congruent sides, congruent angles. Thank you, Spence. So that's 62 degrees right there. Anybody want to keep going? How about the angle adjacent to 62? Because it forms a right angle with it. 28. We're getting there. 28 degrees. Good job so far, everyone. We're getting there. Anything else? Now let me focus your attention here. ABCD. That's a parallelogram. So do I know my properties or not? Anybody remember consecutive angles? Angles next to each other in a parallelogram are supplementary. So this angle ABC, this angle will be, that's 51. Those two are supplementary, so 129. How's that sound? No? Yeah? 129? All right, where am I going from here? Remember, I need to get to that double green angle there. Go, Abbott, go.
Do 129 minus 56 from adding the 62 and subtracting that from 180.
Okay, so here, Abbott's taking, and correct me if I don't understand you, BEF. Everyone see that triangle? BEF, where you know that's 62, that's 62, and we know there's 180 degrees in every triangle. Is that what you're doing, right?
Yeah.
So 180 minus 62 minus 62, what do you got?
56.
That's 56 right here. And I know those two angles have to add to 129, so how can I find the angle next to it? Subtract them. And I think I can do that in my head. 373. Yeah? All right. I think I'm good now because now I have 28 and 73, and the third angle is the missing one I'm trying to find. So 180 minus 73 minus 28. And that'll be, what's that one? That's 1. That's 101. 79. My final answer, 79. Look, and that's the way we saw how to do it. I saw how to do it. There may be other ways around it, sure. All right, but that's the way we got to it. All right. It's up to you guys. Leaving you a little bit of time now. All right, if you want to start the ones I suggested, go ahead. You can start anywhere you want, but you know where the answer keys are. And every day I'm going to give you more and more time to work. Thursday's the quiz. Make sure